Today's topic is about slope. Our objective is to be able to identify and name points, lines, rays, and segments, and identify the slope of a line given 2 points or a graph. So first, when we talk about a point indicates a location and has no size. It is always written as an ordered pair, parenthesis, x, comma, y, and is notated by a dot and a capital letter. For example, if we're looking at the location 2, 3, we would go over 2 units on our x axis, and then we'd go up 3. 1, 2, 3. This location we would indicate with a dot, and we can name that point A. And I can say A is at the location 2, 3. A line is represented by a straight path that extends in 2 opposite directions forever. It has no thickness, and it contains an infinite number of points. Points are considered collinear, co meaning with, so it says within a line, when they lie on the same line. They can be notated with a line with arrows on both ends over any 2 points along the line, such as A, B. So if we have a point here at 1, 2, and here at 4, 0, we can draw a line like that, kind of, and indicate that it will go on in both directions forever. So any point along that line, and there are infinitely many, would be considered collinear. And if this is point A and this is point B, then we would write and notate that line using the little arrow over our letters A and B. And that line would be congruent, the same as BA, because they're both going through those points and they extend in both directions forever. Now, a ray is a part of a line that consists of one endpoint and all of the points on the line on one side of the endpoint. One arrow, I think, is what this is. And all of the points on the line on one side of the endpoint. So it can be notated with a line and one arrow over the endpoint. So for example, if we have ray AB, we could have A here, and then B could be right here. And if we're going to have our line, ray, it would go like this, and we would draw the arrow, where A is our endpoint. So when we notate, the endpoint has to be on A, and the arrow has to be through B, right? For example, if we were to write ray BA, then it would show this green ray that goes like this. And the arrow would go through and past point A. So AB is not the same as ray BA. Last, we have a line segment. A line segment is a part of a line that consists of 2 endpoints and all of the points between them. It can be notated with a line with no arrows over the 2 endpoints, such as segment AB. So if we have here and here, we just draw to connect both of those points. That would be our segment AB, right? And so there are no arrows when we draw that segment. So similar to a line, segment AB would be the same as segment BA, because they're both endpoint to endpoint. So for our first teacher example, if we're given this diagram, we want to name all the distinct points, right? So points are named with a point and a capital letter. So we would have point E, F, and G. Now it says to name a distinct line. A line has two arrows. It continues on both sides infinitely. But if we look at this diagram here, there's an arrow going past the G, but not one going past E, which means there are no lines. Now, if we're going to name a distinct ray, a ray has one arrow and one endpoint, which means, let's say I want to name this ray. So we're going to have our endpoint at F, and then the arrow going past G. And lastly, if I want to name a line segment, let's say I start here and I want to end here. I have my endpoints at F and G, and I can name that, E and F. So you can have segment EF. Go ahead and try the student example on your own. Okay. Now the second topic we're going to touch on is slope. Slope measures the steepness of a line as a ratio of vertical change over horizontal change, right? And very often you might hear this phrase, rise over run. But I really want us to think about rise as your change in the y direction over the change in the x direction. And we can simplify that by using this Greek letter delta y and delta x. All right. This equation y2 minus y1 over x2 minus x1 will be provided for you on your equation sheet, but is a useful equation to have memorized. So, teacher example number 2 says you're flying from Dallas to Boston. What is the slope of our trajectory? So we have to first find Dallas and Boston, and I'm going to find their coordinate points. So Dallas is at 2, -4, and then Boston is at 7, 8. So we're going to use our slope formula, y2 minus y1 over x2 minus x1. And then label our points, x1, y1, x2, y2. And then go ahead and plug it in. So 8 minus -4 over 7 minus 2. We can plug this into the calculator, or 8 plus 4 is 12. 7 minus 2 is 5. So our slope is 12 fifths. Go ahead and try student example number 2 on your own. And then at the end, go ahead and answer your reflection questions. If you have any questions about any of the topics, this is a very good place to note them down.